Okay, welcome to page 3 of the study guide. This one is to find the height of a mountain. See if this that might be better, a little more light. To find the height of a hill or mountain, a woman measures an angle of elevation to the top of the hill to be 24 degrees. She then moves straight backwards 200 feet and measures the angle of elevation to be 22 degrees. Find the height of the hill. Of course, and we got a picture already drawn for us, which is nice. So we have this length here, but we don't have that length. We don't have enough of a known right triangle, so we're going to have to use something else. This is that angle here. And then we'll make this angle over here teal. Oh, so looking at this, we don't have enough of a single triangle, so we're going to have to do a little bit of extra math. This is a straight angle. So one thing I know about a straight angle is equal to 180, so this is supplementary. So we can just take 180 and subtract 24 degrees to find that one right here. So this would be 156 degrees. And if I know that angle, then I can definitely find this angle up here. So 180 minus 156 is 24. Minus 22 is going to be 2 degrees. So that's going to be 2 degrees. And now we need to figure out, so our goal is ultimately to figure out h. So we can definitely, we can definitely figure out whatever this value is right here. Because I do have a side and I have all three angles, so I can use angle, side, angle, or angle, angle, side, either one. Any way you look at it, it's going to be law of sines. Two angles and a side. So the angle opposite of 200 feet is 2 degrees. So I know that sine of 2 degrees divided by 200 is equal to sine of 156 divided by the angle across, that's just x. If we cross multiply on this side, I'll have 200 times sine of 156. And over here, I would have x times sine 2, but I can go ahead and divide by sine 2 to get x by itself. And then type that into the calculator. 200 sine 156 divided by sine 2. And we get 2330.9. So x is equal to 2330.9. Okay. Now, if you instead found this length right here, that is also totally okay. There is more than one way to do this. We just need enough stuff. Now, how does that help us? Well, if we look right here, now I have this triangle right here. There are 3 triangles we get to work with in this problem. They're all stacked on top of each other. But we have that big right triangle right there. If I wanted to sketch this out all by itself, it would look something like this. This is 22 degrees, and I know that this is 2330.90. So now I have a right triangle and I have a known angle, and I'm looking for the height. With right triangles, we could use law of sines again because this is 90 degrees. That's a completed ratio, but we'll use the much simpler version of law of sines, which is SOHCAHTOA. This is the opposite side over here, and that is the hypotenuse. So we know that sine of 22 degrees is equal to opposite, which is our height, divided by 23 30.90. Multiply both sides by 23.90, and we get sine 22 times 23. Oh, wait, we can just copy and paste that up there. And you get 873. So h is equal to 873.17 feet. Done. A steep mountain incline, a steep mountain is inclined 77 degrees to the horizontal and rises 3,000 feet above the surrounding plain. A cable car is to be installed that will connect the plane to the top of the mountain. The distance from the foot of the mountain to the cable car, entry loading area is 1,200 feet. See the diagram below. Great. Find the shortest necessary length of the cable. So, again, always sketch. I know we've given sketches, but always sketch. It always helps to draw things out, and that way we can see exactly what we're looking for. So we are looking for the cable that will take you from the loading area to the top of the mountain. So we're looking for this, the length right here. I'm just going to call it D for distance. So that's what we're looking for. Now we need to figure out what we have. Well, this is part of that triangle there. So this is 12,000 feet. Oh, sorry, 1,200 feet. 1,200 feet. We need more information. I don't have enough for this triangle alone, but I do have that 77 degrees. So we can know that this is 180 minus 77, which is 103 degrees. And what else do we know here? So that is 3. That is 3. I think we're going to have to go with this right triangle first. So I think what we're going to need to do is I do know enough about this right triangle that I'm highlighting, because right triangles we don't need to know as much. We have an angle here, and we need this side of the triangle, so that's the hypotenuse of that particular one. So we need to find, we'll call this x for now. And so if we find this angle, that'll help us out with this triangle over here, or this side, that'll help us out with this triangle over here. So let's start with that. I know this is 77 degrees, and this is 3,000. So I can, again, use a right triangle, so I can go back to the much easier SOHCAHTOA, it's less complicated. So I know that I have an opposite, and I'm looking for the hypotenuse. So I know that sine of 77 degrees is equal to opposite 3,000 over x, whatever that is. Do the rearranging, and you get x is equal to 3,000 divided by sine of 77 degrees. So that means that x is equal to 3,078. That sounds about right. It's the hypotenuse. It has to be longer than that. So that sounds reasonable. 3,078.91 feet. So now that we have that, we have side angle side. So that gives us side angle side. So we're going to use law of cosines to find this distance here. So law of cosines, d squared is equal to 1,200 feet, so 1,200 squared, plus 3078.91 squared, minus 2 times 1,200 times 3078.91 cosine of 103. And then if you want, you can just say, go ahead and square root the whole thing. And you get second square root 1,200 squared 3078.9. Oh, nope. 0.91 squared minus 2, 1,200, 3078.91 cosine 103. Oh, and we end up getting 369. Make sure I typed all that in right. I mean, it looks reasonable. Does it say 36? That does not look reasonable at all. That is way too long. Okay, what do I do here? Oh, I think I forgot to put an addition. Second, insert, addition. So the most challenging part about this test is going to be making sure you type stuff in correctly. That looks more reasonable, 3,547. So D is equal to 3547.10 feet. Make sure you're typing stuff in the calculator correctly. Those small typos, most of this test is going to take just typing in the calculator. So be thorough, have an idea. I was able to look at this number here and know that is way too big because the mountain isn't even close to being that big. So I wanted to go ahead and check my work, and I did find a typo. So it's good to have that intuition. Okay, a bit of a gear switch here. We're going to the sum and difference of angles and the double of angle formulas. So find the exact value of sine of 10 degrees, cosine 20 degrees, plus cosine 10 degrees, sine 20 degrees. Well, this matches our, so if we call this alpha and call this beta, this beta, that's another alpha, this is beta, and we notice that this is sine, cos, cos, sine. That is our sum formula for sine. So that tells us that this is going to be equal to sine, according to our identity sheet, of alpha plus beta. So that is sine of 10 plus 20 degrees, which is just sine of 30. And if my memory serves me, sine of 30 is a special angle, and it is 1/2. I'm fairly sure. And there we go. Okay, and that is the end of page 3. I'll see you guys for the third and final page.